Hey guys, welcome to a new video. I know you were all expecting the 24 volt cob LED strip video, and that is in the works. I've actually already updated the power sheet. You might have to refresh your browser with all the new 24 volt strips in there, but I think I'm moving that video to next week. So this week we're going to take a look at all the Dig lineup and how it arrives if you order it from Allnet. And also try to structure it in such a way going from the Dig-to-Go, which is a very small board and meant for mobile and small applications, to all the way up to the Dig-Octa, which is more meant for lots bigger and feature-rich installations, basically. And I'll go over each board and we'll hook it up, and I'll tell you its pros and maybe its cons, etc., and what each board is best suited for. So let's get started with that right away. So let's go to the desk view, and I have this this giant bag that I got from Allnet, and well, let's unpack that first. So here we have a Dig-Octa brain board. Okay, let's see. This is a quinled-dig-quad AB. Okay. The Uno AB, so AB stands for antenna board, but I'll clarify that once we get there. We have an ASP32AE, again, I'll clarify that later. We have a little data booster here. Let's see here, what's this? Oh, it's an ESP32ABE, again, clarifications later. And then the AE Plus full option. But, yeah, we'll get to that. And here we have a Dig-to-Go board kit with SK6812 5 meters for EU. We're going to start with that. There's one last box which wasn't in the package because I already had it, and that's an Octa PowerBoard 5. But let's start at the beginning, and as I mentioned, there will be jump links in the description. So that you can actually go to the controller you're interested in or to the section. We're starting with small, maybe even mobile projects, and then finishing with big and large, etc. So the first thing we're going to start with is this Dig-to-Go board kit with SK6812 5 meters, and this should have everything from the Dig-to-Go itself, the pigtail, the LED strip, the power adapter, and the USB-C cable. Let's take a look at that together. Here is the power adapter with indeed the EU plug, which I need. I can feel it. Oh, aw. Okay, here is the USB-A to USB-C cord, because this power adapter is actually USB-A, but I've fully tested it, and this is perfectly capable of the 3 to 3.5 amps that the Dig-to-Go can handle. Okay, so let's move that to the side a little bit. Up we have the little pigtail wire. Okay, and the box is empty. And this is the LED strip. It's a 60 LEDs per meter SK6812, so RGBW, and oh, of course, we also have the Dig-to-Go. And it's in warm white. We only sell the warm white version because we basically can't stock all of them. So, it's a standard LED strip with an adhesive coating on the back, and it's IP65, because I generally like using those best. So let's roll off a little bit here. And let's take out the Dig-to-Go. Now, quickly about the Dig-to-Go. The Dig-to-Go is a fully encased product that is powered by USB-C, and it's intended for limited 5 volt applications. So up to about 300 LEDs you can run with a Dig-to-Go. It'll be a little bit power limited, but it'll still give you very decent brightness. It has a little button, it has a digital microphone on board, it has an IR sensor, it has an ESP32 inside with a level shifter, And there's even a relay circuit inside that cuts off all power to the LED strip when you turn it off in WLED, while WLED itself stays online. Now, you can't really integrate these plugs into a case, so there's a little pigtail cable that comes with it, and it just plugs in like that. And then you take your LED strip, which then plugs in over here. Now you can wonder about, why does it have these extra wires? If you're running multiple LED strips, and we'll look at that with the Dig-Uno and Dig-Quad, you can use these for power injection, but since we're running a Dig-to-Go, that's not really an option, since, well, this is limited in power by design because it needs to run off of USB-C. So we take the USB-C plug it in there, we take the USB-A, and we plug it in there. And now let's put this in the socket, turn the socket on, and there we go. Now, as you can immediately see, these colors aren't orange, so this is likely not the way it should be, and that is because it's pre-configured for WS2812B, but we're running RGBW, so not RGB, SK6812. But let me quickly go into the settings and change that. Actually, let's do that together. I took out a phone, and here we go to our Wi-Fi settings. And here we should see a WLED-AP. The default password is WLED1234. And here we can use the Wi-Fi settings to connect it to our own Wi-Fi network. We're not going to do that right now, but we're going to go to the controls, config, LED preferences, and here we can see it's set to WS2811 or 281X. Fine. We're going to change that to SK6812. We indeed have 300 LEDs. Let's save that. And bingo, it immediately works. Now we can do some more changes here, like, okay, we have a 3.5 amp power adapter instead of the 1250 it's default set to. And now you can already see it gets a little bit brighter. And if we go back to the controls here and do some kind of effect, well, that immediately works. It's a bit too bright, isn't it? There. So that is the Dig-to-Go. The Dig-to-Go is meant for limited projects where you don't want to do any power injection. This LED strip can get brighter with power injection, but the Dig-to-Go doesn't provide for that. But even with its limited budget of 5 volt, 3 amps or 15 watts, it can provide a very good and decent light output up to about 300 LEDs, I'd say. Only 5 volt, but yeah, it has a little button, and well, it just is a very tiny form factor. You can easily work away or stash somewhere. You want some LEDs and you don't want 10 or 15 meters with lots of power injection points, or 12 volt or 24 volt or something like that. A very easy to controller to get started with, as we just did in about a minute or 2 minutes or so. Right. I think that's most about the Dig-to-Go. I might mention previous controllers when I'm doing the next one, when I remember certain features and such. But let's move on to a Dig-Uno. The Dig-Uno comes in a nice little cardboard box, and this is the AB version. Now you can get 3 types of versions. The AB, which stands for antenna board, the AE, which stands for antenna external, and the ABE, which stands for antenna board Ethernet. I make these options available so you can buy what you need. If you're not going to do any real-time pixel shows and stuff like that, you likely don't need Ethernet, and Wi-Fi is fine, but I want to provide the option or not make you pay for something you don't need. So that's why they're modular in that sense. Comes in a baggie. Oh, here it is. Should have one of those cut lines. And this is the Dig-Uno. Now the Dig-Uno can handle a lot more. Instead of only being 5 volt, it can do 5 volt, 12 volt, or 24 volt. There used to be a jumper where you needed to set the voltage you were running, but that's now all auto integrated with some custom circuitry I've done. you can remove this top board here. There is a little plastic spacer. You can either leave that on there or take it off. It's mostly to protect it during shipping. It has 2 output channels instead of just 1. Here you can see LED 1 and LED 2. And those also have a resistor switcher under the orange foil here. You can take off that orange foil there. And then you can use this switcher to switch between a 249 or a 33 ohm resistor. Now that has to do with conditioning the data signal for the type of cable you are going to be using. Where with the Dig-to-Go, you're basically not going to use much more cable than the pigtail, so the controller is right there. With the Dig-Uno and Dig-Quad and Dig-Octa, you can easily make the data cable 5 meters, so 16 feet, or even 10 meters, generally works up to 32 feet away. And depending on the type of cable you have, either 2-wire with power and then a separate data wire, then you need 249 ohm, or a 3-wire cable or 2-wire where data and ground are running together on the same cable bundle basically, then you need to flip the switch to 33 ohm, which you can easily do just like so. Next to being able to handle 12 volt and 24 volt next to 5 volt, it also handles a lot more current. Now I'd say the Dig-to-Go is good to use up to 10 amp continuous, but the board can handle more since I used a lot of copper and planes and stuff like that on there. Still, in regards to where I'd position it, I'd say that about up to 10 amps is ideal. Now that means you can run a SK6812 with a front, middle and end injection, so you have to do more wiring at full power output brightness, or you can run for instance 12 volt strips and then up to 10 meters with WS2815, or 24 volt with the addressable neon. You can also run up to 10 meters easily running just this single little board. You'll have to splice the power on the outputs to do injection, but if you really want to do injections and fuse each injection line individually, which I would recommend, you need a Dig-Quad, but we'll get to that in a minute. So next to that, as I mentioned, it comes with a custom ESP32 I've designed myself, and next to that there are some other features on the board. For instance, it has some power conditioning to smooth out the power, my custom level shifter with the resistor switchers, as I mentioned. It's fully onboard fuse protected too. It can have up to 2 power inputs if you want to use a relay to turn on your main power supply and keep the board online, so you can use the WLED on and off function with a relay. You can use that using these I keep calling it 5 volt EXT, but it's VEXT function. You can feed in extra power here for that from, for instance, a phone charger. There are lots of pins on both sides here, which you can use to connect extra things like a microphone or more switches or sensors or a relay, things like that. And, well, as I mentioned, it comes with 3 ESP32 options. So here we have the AB, so antenna board, where the antenna is, well, integrated onto the board. And let's take a look at the AE, so that's this guy. So that is antenna external. It comes with the external antenna included, like so. Oh, wait, didn't take the antenna out, like so. And basically what you do is you take off the ESP32 board, you can insert it onto the Dig-Uno, make sure to align the pins properly. Generally, it's best to look at the back. If you receive it from us, everything basically fits together. You take that little pigtail, antenna pigtail, and you put it on there like so. So you kind of push it down with your nail. This is just a little protective cover. And then you can screw on the antenna like this. And this can be mounted into a box wall, for instance, or something like that if you want to use an external antenna and have the QuinLED Dig-Uno inside of your box. So now we've converted this board antenna into an external antenna model. And generally the external antenna, if you need more range or a better signal, something like that, the external antenna can certainly help with that. If you had spotty Wi-Fi with this one, you'll likely have better or good Wi-Fi with the external antenna. There are limits, of course, but yeah. What if those limits are, you can't overwin those? Then there's a third option, and that is the ESP32AE. And that stands for antenna board with Ethernet. So let's take that out of the box. So this is basically this module, but with custom length longer pins with another module stacked on top of there. We can remove this protective foam. We can take off the external antenna version. Oh, well, sometimes the fuse comes out. That's fine. And then we can insert this by lining it up correctly again. The Ethernet port faces forward. Let's put the fuse back there. And now we have a version that has an Ethernet port. All right, so that kind of explains the options and how the Dig-Uno is different than the Dig-to-Go. 12 volt, 24 volt, up to 2 data channels, much more power handling, up to 10 amps, I'd say. The board can handle more, but you'll get into wiring issues, and better power stabilization, etc. Just basically if you want to run bigger projects and full power that the Dig-to-Go doesn't support, the Dig-Uno does, up to a limited amount. I'd say generally for 12 and 24 volt, you're good for up to 10 meters. And for 5 volt, it's between 5 meters and 10 meters, so 16 and 32 feet, depending on your power requirements. Let me quickly hook up a strip and then show you what that looks like. Okay, we have the Dig-Uno hooked up with a pigtail, and this is actually for a WS2815 with a backup data wire. Now the backup data wire is the blue one, and I've hooked it up to ground because the first pixel will then generate the backup data, and green is our primary data, which is hooked up to LED 1. Let's take the ESP32 with Ethernet, like we said, and put it on there like so, and you get a nice tight little tiny package which doesn't take up a lot of footprint or space. I have a 12 volt WS2815 strip here to show you that it can support different voltages than basically the Dig-to-Go. All Dig-Uno, Dig-Quad, and Dig-Octa support 5 volt up to 24 volt. It's just the Dig-to-Go that's limited to 5 volt. Okay, right, let's power up the power supply. There. And we can already see that the first part of the strip is lit up, and that's because there's some pre-configuration. Of course, it comes with WLED flashed onto everything out of the box. Let's join the WLED-AP again, and go to the controls, configuration. Let's up the power. Let's turn off the power limiter. We don't need it in this setup. And we have 144 LEDs attached. Save. Okay, that worked. And I don't know if the right type of... Yeah, okay. We have the Ethernet type firmware on there because this is the Ethernet module. So it's basically flashed with the Ethernet firmware. And it's already set to QuinLED ESP32, which is the correct type for this module. So let's see if we plug in an Ethernet cable, if it comes online. Yep, it does. Awesome. And now you can go into your router, look up the IP it got, or you can use the WLED native app, for instance, to scan for it if it's the same network. And you should be able to use this Dig-Uno with a hardwired Ethernet connection instead of having to rely on Wi-Fi. Okay, well, let me quickly look up that IP and show you in effect. Okay, I've connected to that IP, so let me show you real quick. Here is the browser, and if we look in the info screen, it comes with 13.1 out of the box. Newer boards are shipping out with version 14 already. but you can easily update your own boards either OTA or using a USB flash. And we do recommend a USB flash if you're going from 13 to 14 using install.quinled.info. I'll show you that in a second real quick. But just to show you that we're connected using Ethernet, our signal strength is 100% with 0 dBm. And well, we can change the color or do an effect again, right? And that's running nicely over Ethernet. So that's a lot of very different options than the Dig-to-Go. We're now running a 12-volt LED strip with Ethernet. As I mentioned, we have a website where we have a lot of pre-compiled settings for WLED, just like it comes out of the box. And sometimes you want to reset your controllers to the default values. This goes for the Dig-to-Go, Dig-Uno, Dig-Quad, and Dig-Octa. We have all of them on there. You can either do that using USB or OTA flash. But if you look at that website, you basically just go to the board that you have. It has some instruction text over here. You can select the version you have. That won't show up, but here I can select Ethernet. And then you can just hit install to do it over USB. Or you can find custom compiled binaries over here. Right, let's remove that browser again. This all works fine, so let's turn that off and move on to the Dig-Quad and see what differences we have there. Okay, so we have the Dig-Uno over here. Let's take a Dig-Quad. There, this is a Dig-Quad AB. But as I said, you can get them with the AE or ABE option included out of the box. And there, that's a Dig-Quad. Now, the Dig-Quad shares a lot of similarities with the Dig-Uno. Again, you can take the ESP32 board off, and this part kind of looks the same. You have the socket, you have the extra pins for 5 volt, 3.3 volt, and some GPIO pins to hook up sensors and buttons and things like that, or relays. You have the resistor switcher here in the middle, except now you have 4 channels instead of just 2, and that's these 4 terminals. Then this board has integrated power distribution and fusing. So here you can see 2 much beefier input terminals where you can connect 2 large wires from the same power supply. So don't connect 2 wires from 2 different power supplies, that's not supported, but you can use more copper between the power supply and the board. That's because here I said it's recommended up to 10, maybe 15 amps. This board can easily do 30 amps continuous. And that means you need much beefier connections. Basically, the amount of copper you have going out, you also need going in. So on this side, we use nice and thick cables. I can actually get some here. For instance, these are 2 times 12 gauge, and we can connect those to the terminals like so. Okay, there we have it. Negative goes to this side of the board, there's a large ground there, and positive goes to this side of the board, as noted by the symbols over here. And then positive goes into these 5 fuses, which are then distributed into these 7 output terminals, and on this side you also have 7 negative output terminals. And as I said, in the middle you have your 4 data connections. Those are all individually level shifted, so there's a level shifter per channel, so that if one of the level shifters dies, for instance, the other channels shouldn't be affected. It also has the resistor switcher I mentioned before to adapt between what type of cabling you're using. And, well, the main thing is power distribution and power handling. This can easily do up to 30 amps, as I mentioned, and especially if you're running 5 volt strip, for instance, and you want to run 10 or 15 meters, you're going to need 3 to 4 injection points, and you kind of want to fuse those all individually. Well, that's what you can do with these terminals. Also for 12 and 24 volt strip, depending on the lengths you're running, let's say you want to run 20 meters of 24 volt strip, you still need a front plus end injection, or maybe even a front plus middle plus end injection. and this board is perfectly suited for that. So in the grand scheme of things, as we are so far, Dig2Go, easy to use, setup in a minute or whatever, USB-C power, but because of that it's power limited, but running a single strip, if you weren't planning on injecting anyway, the perfect device. 5 volt only, but integrated microphone, things like that. Then we have the Dig-Uno, which can then do 12 volt and 24 volt also. Can also handle a lot more power, so you can actually do a power injection or two. It has 2 data channels, it has a resistor switcher, auto voltage sensing for the board itself, etc, etc. And then if your project becomes even bigger, you have the Dig-Quad, which has integrated power distribution for your power injection lines, big capacitor again for power smoothing, auto 5 to 24 volt. It has bigger VEXT input terminals if you want to run a relay and a second power supply again. And yeah, for medium to larger size projects, the Dig-Quad is a very competent and easy to use board. Now I'm not going to hook up the Dig-Quad like I did the Dig-Uno. I think the basic principle is clear. You have negative, you have 4 data channels, and you have positive. That way you can also hook up multiple strips, either to do power injection as I mentioned, or running multiple separate strips that do their own function or their own effect and things like that. That's all possible. But what I would like to highlight is another ESP we haven't looked at yet, and that is if you want either audio, so a digital microphone, an IR receiver, an SD card slot, or 3 extra output pins on a Dig-Uno or a Dig-Quad, and that is the AE+. So it's basically the same AE base, so the external antenna base, but it has an extra top board just like the Ethernet variant. So we don't need this because we already have the antenna here. Let's take it off of this one there. So if you look here, you get the same ESP32 board, but it has a different top board on it. And here we can see the micro SD card slot. We can see the IR receiver, the digital microphone, but the microphone hole is actually on the top over here. And then it has 3 extra outputs, and the GPIO numbers are mentioned over here or in the pinout articles, which each of the board has on quinled.info. Right, so you can get this board in 3 different variants. It's all the AE+, but not everyone needs all the functions. Some might want a digital microphone and IR receiver, but aren't interested in the SD card slot and the 3 extra channels. Other way around, some might want the 3 extra channels and the SD card slot, but they're using it in a Christmas show running off of the SD card using ESP pixel stick firmware instead of WLED. Then they really don't need the microphone or the IR receiver. And some might just want a versatile board with everything on there, and that's where this full option comes in. But there's also the SD option and the IR plus microphone option, so you can choose whatever you need. It goes onto the boards just like all the other boards. It just slots in like this, and now we have a Dig-Quad with 4 plus 3 channels that we can fully utilize. Or we can use the digital microphone to have it react to real-time audio effects. Currently, this AE Plus version is still a separate purchase and can't be bought bundled with the board. We are working on that, but it's a bit hard in the back end, handling all the multiple versions and keeping them in stock and testing them, etc. That's because all combinations that we have are pre-tested by Allnet. So nothing leaves Allnet that hasn't been tested. And adding more variants to that, because this would mean 3 extra variants, means a lot more that we need to keep in stock, because if we have to test them before shipping out, that takes too long. So everything gets tested in one big batch and then pre-configured in these little boxes and put on a shelf, and then it can immediately be shipped out once you order it. Same goes for DrZZs, by the way. He gets the same variants, And well, they're also already pre-tested and he just ships them on from US local. Okay, so that's the AE Plus variant I wanted to highlight. You can buy that as an extra upgrade. You'll be left with, you know, an ESP32 you might not be using, but it's a generic ESP32 with a onboard flashing circuit, so you can use that in any other project you want. Maybe you want to connect some sensors. All the GPIO pins are listed here on the back, so it can easily be used for that. So I hope that explains what the Dig-Quad is capable of, but there is one bigger board in the lineup, and that is the Dig-Octa System. And the Dig-Octa System is called a system because it consists of two types of boards. First, we have the brainboard, the brainboard ESP32-8L, as I call it, and that is because likely in the future there's going to be different versions you can buy. Currently, there's just this one. It comes in this nice little box, and it, of course, also includes the external antenna again, because it has an external antenna ESP32 by default. But it also comes with a nice little card, which explains what all the connections do and where they are. Oh. And then it comes with a baggie with connectors and a baggie with standoffs. And we'll get to that in a minute. I always need to find the little dimple to be able to tear it open. Can't find it today. There. So the brainboard is about the size of a Dig-Octa, actually, as you can see here, but it doesn't do anything in regards to power delivery. What it does have is basically all of the options of the previous boards, except maybe if you wanted to use a digital microphone. So it has the ESP32 with external antenna, but it always comes with Ethernet integrated. It always comes with the SD card integrated, and it has up to 8 LED output channels. Now, there's a bit of a caveat there. The ESP32 is limited in amount of power, so I'd recommend sticking at max to about 2400 LEDs per ESP32 board. But that's where the system part comes in. So I'll show you that in a second. First, what I wanted to show you is basically this board comes with some convenience upgrades over the Dig-Quad. It uses higher quality terminals, not so much in power delivery, but in usage. So instead of using the spring style terminals, this one uses rising clamp terminals, as they're called. Yeah, I can't really show you that. They're already open, okay. But it makes it a bit easier to insert the wires and the ferrules, basically. It has a relay circuit like on the other boards, but then a dedicated relay output terminal, which always outputs 5 volt ground and a 5 volt trigger signal. So even if you're running this board at 24 volt, it still outputs a 5 volt signal. That means you can just wire the 3 wires of the relay into here, and that makes it a bit easier to use than on the Dig-Quad or especially the Dig-Uno. It comes with 2 dedicated button terminals over here. So if you wanted to connect buttons, you don't have to mess with DuPont wires and things like that. You can just screw them into here. And then another unique feature of this board is that it basically has 3 ways to power it. You can power it using these 2-pin plug terminals, again 5 to 24 volt, or you can power it using USB-C, like over here, or you can power it using Q power post, and I'll show you that in a minute. A unique feature of this board is you can power it with all 3 at the same time with different voltages, and it'll just use the highest voltage that's available at that time. And if you, for instance, then switch off one of the power supplies, it'll automatically stay online and use the next one. So it comes with these standoffs, and that is to basically stack this board onto a power board. So let me get those out. All right. Let's quickly take a look at the power board then, because we need both to build the complete controller. Although both products can be used standalone, so you can use a brain board by itself and do everything power related by yourself. Generally, I would recommend using a stacked configuration. So using a brain board plus a power board, or a combination of the two. Again, this one comes with a nice card where it shows you what all the connections do, and a little thank you note for purchasing it. The box with the extra stuff is stuck. It comes with an extra little box which has all the accessories in it. Again, it has lots of, I didn't even explain that. In the Dig-Octa lineup, there are 3 types of power boards you can get. The Power 5, which is this board, that is capable up to 50 amps and has 12 output terminals. Now, these terminals are the pluggable style, as you can see here. And as you could see on the card, they carry positive and negative on each of these terminals. They're all individually fused, and it also has input fuses because of the high currents involved. It has these nice beefy terminals again, but now you can hook up to 3 wires to actually support 50 amps continuous, because the more amps you want to run, the more copper you need. So you can hook it up with 3 times 12 gauge or 10 gauge. And then use all these output terminals to their max potential, up to 50 amps in total. Now it has 10 amp and 5 amp fuses. If you do an edge injection, you use up to 4 amps. So you use one of those 5 amp fuses. And then if you use a middle injection, you use these 10 amp fuses, because it can go up to 8 amps. That's a little more theory than to go into here. So this is a Power 5. Next to a Power 5, we also have a Power 7, and I'll show you a picture of that here. The Power 7 has 16 output terminals, but it doesn't feature these pluggable terminals. That means that if you're stacking multiple on top of each other, which is supported, you can't really reach the screw terminals anymore, where with the pluggable terminals you can. So that depends on the choice you want to make there a little bit. The terminals are, however, a bit larger, so you can use up to 12 gauge wires with ferrules on the Power 7, where the Power 5 goes up to about 14 gauge with a wire ferrule, and these terminals have a little bit more voltage drop if you're running close to 8 or 10 amps, where the Power 7 is much better in doing that because it has much beefier terminals, basically. So it depends on the project you're doing, which would be best suited, or kind of just like which type of terminal you like best, and if you're going to stack multiple or not. Now, as I mentioned, these boards are meant for stacking. No, wait, I forgot a board. There is also the Power 7 HC. Now, the Power 7 HC stands for high current, and that's basically a Power 7, but now it has a much thicker copper planes and a different input stage, allowing even thicker wires to be connected, and it allows up to 100 amps of continuous current. So especially if you're doing a 5 volt project with everything nearby, not like 10 or 15 meter runs, being able to use a lot of current is, well, a feature of that board. Now these go to 50 amps, which I say is pretty decent. For instance, paired with an LRS 600-12, that gives you 50 amps of 12 volt. That pairs perfectly with these Power 5 and Power 7 power boards. Right, so stackable, what does that mean? Basically, that means we can put this board, the brain board, like so, and build it as a one coherent controller. So let me do that real quick. Okay, and there you go. This is a fully stacked and, well, configured, I guess, Dig-Octa System board. We have a Power 5 on the bottom with now all the plugs inserted, and then a Dig-Octa brain board on top. And the modularity of the system, and you get all the hardware included, means you can stack multiple power boards if you'd want to, and those can actually even run different voltages, so 5 volt, 12 volt, or 24 volt, and you can stack multiple brain boards if one isn't enough for either the amount of channels you need or for the total amount of LEDs. As I said, kind of limited to about 2500 LEDs per board. If you need more, you basically just stack on another brain board, and especially if you're running a show using the Ethernet connection or the SD card, that works pretty seamlessly, and you can use multiple controllers to control your props or whatever you're doing. Now, as I mentioned, the total amount of LEDs you can drive is basically the same as from a Dig-Quad, but this just brings a lot of convenience features. So it has much better screw terminals, as I already mentioned. It has better bulk capacity on the power board. It has better power handling on the power board. It even has a per port capacitor to smooth power as much as possible, so that in any situations your LEDs won't be starved for power. It has a broken fuse indicator light per port, so if one of these fuses pops, you can easily see which one it is and replace it real quick. And as you can also see, once this is stacked and as a single level, you can still access these fuses and replace them pretty easily, especially if you take these connectors out. If you stack multiple power board, that becomes a little bit harder, but it is doable with a special tool. But if you're looking for an upgrade or just an easier to use Dig-Quad, this certainly fits the bill. And if you're looking for a larger system but don't necessarily need to upgrade to one of those few $100 boards, you can get multiple power boards or multiple brain boards and stack those together. Right? So I just wanted to give you an impression of all the boards that the current QuinLED Dig lineup has. Wait, we forgot a board. I need to dig for it. Hold on. There, I found it. It's this little guy. Let's take a quick look at that, and then let's discuss again what boards are best for what. This is a QuinLED data booster board, and I kind of created it when I noticed that you needed two different value resistors for different cabling situations. So here you can feed in, on this side, you can feed in power and data, either 5 volt, 12 volt, 24 volt, or even 48 volt if you're running that, but the other boards don't support that. And I don't know of any 48 volt LED strips, for instance, and well, doesn't matter. It supports that, and here you have a resistor switcher, which again switches between 249 and 33 ohm. Now this feature has since been built into all of the Dig boards, except the Dig-to-Go, because it's not really meant for longer cables. So you don't need it for that anymore, but you can still use it for gap bridging, for instance. So let's say you have an LED strip and you want to bridge a 1 or 2 meter gap, so let's say 6 to 12 feet. And especially from LED strip, those integrated controllers don't send the data signal that far. You connect one of these boards at the end, and then it'll easily do 5 to 10 meters again, just like it would do from one of the Dig controllers. And you can adapt the signal to whatever is needed for the type of cabling you're using. It also features power injection, so you get the hardware with it to do so. So two of these fork-style crimps, and the screws and the locking nut, so you can put those on here, ground over here, positive over there, and that way you can power inject without having to solder by just screwing in the wires of all the strips and doing it that way. Right, so this is a tiny little board that's useful in some situations, but you know, generally with the Dig boards you're going to need less of these unless your layout basically calls for them. Right. So, one final roundup. We have the Dig-to-Go. The Dig-to-Go is very small, 5 volt only, 15 watt max, so it's kind of power limited, but it's powered by USB-C, which is very convenient because you can use a normal USB-C charger, a USB-A to USB-C cable, or a power bank, so that makes it ideal for mobile applications, especially because there's a relay circuit inside which will cut off all power to the LEDs if it's turned off while keeping WLED online. That way your battery lasts longer. It has some expandability pins, but it's really meant for a single LED strip. You don't want to do power injection, so up to 300 LEDs, I'd say. This is a great board. It won't run the LED strip at full potential, but for normal usage and generic effects, this is great and very easy to use. If you're trying to get into WLED and don't want to mess with hardware, get one of these and you'll be up and running in a minute, right? So after that, we have the Dig-Uno. This now has 2 data channels. It has also the resistor switcher, so you can run much longer data cables if needed. And it supports 5 volt, but also 12 volt and 24 volt power. It has some more power stabilization. It supports much more current. So instead of the 3 amp, we can now easily do 10 to 15 amp. And it has multiple options. For instance, if you wanted to run Ethernet, you pair it with an ESP32 ABE, and now you can run Ethernet. Or maybe you need some extra channels or a digital microphone, although the Dig2Go also has a digital microphone. You can just plop this on top, and now your board has an IR receiver, a digital microphone, an SD card slot, and 3 extra channels, or a subset of those depending on the board you buy. And you can also get the where is it? The AE variant, which is the external antenna variant. So you can use one of these external antennas if you're mounting this into a box. Then, if you're running a bigger project or need more power, you can upgrade to a Dig-Quad. And basically this is the most used board at the moment because it has all the same features as the Dig-Uno, but it has a bit easier to use layout. It can accept much beefier power wires and then does up to 30 amps continuous, where the Dig-Unos I'd really recommend for about 10 amps. And then it has 5 fuses on board with power distribution and reverse polarity protection and things like that. So you can easily do power injection for especially your 5 volt and your 12 volt projects. And it has 4 channels instead of 2, right? And then if you need something even bigger or just want more convenience, you can step up to the Dig-Octa, and that has multiple power boards, whatever suits your needs, up to 50 amps or even 100 amps continuous. Easier to use screw terminals. It comes with the external antenna Ethernet or external antenna ESP32 automatically included, and Ethernet and the SD card slot, and 8 output channels, easier relay connection, multiple power supply support, button pins, even an I2C temperature sensor, I2C terminal, so you can connect extra I2C devices. All in all, a much beefier and I guess luxurious version of the Dig-Quad, because they can both handle about the same amount of LEDs. But if you need more LEDs, you can just stack on a second brain board on top. Let me show you an example of that. Hold on. Right, so here's the board I used in the recent 5 volt Cobb LED video. Doesn't like, yeah, there we go. So this is a single power 7 with then 2 brain boards on top because I needed more total LEDs. It's connected to an LRS 600-5, which can deliver 5 volt up to 100 amps. Now a single power board can't handle that, but 2 power boards could, and it's connected using nice beefy wires on a custom 3D printed mount. So this way it becomes a nice, on top of power supply, fairly space efficient controller you can put into a box and, use it. So the Dig-Octa system, very expandable with multiple power boards if you need, and or multiple brain boards if you need them for, well, more advanced setups basically. Now, I probably forgot a lot of things, but I hope the unboxing experience, like you'll receive them from either Allnet or DrZZs, was pretty clear. And I showed a little bit of the setup and how the boards differentiate from smaller to easy to set up projects to larger. I want to do all of my roof lines and I want to use 5 or 12 volt mixed and lots of data channels and real-time data fed from X lights using Ethernet. You can then use a Dig-Uno, Dig-Quad, or especially a Dig-Octa. If there's any questions about that and what board would be best for your situation, leave that question down in the comments, or better yet, come to the Discord server where there's lots of people next to me available that can look over your plans and work with you together what board would be most suitable for that. Working on those plans, I have a dedicated video, a dedicated LED strip power injection video, which takes you through a lot of steps, guide step by step with a document and everything to calculate what you need. And then with those numbers, we can easily say which board would be best suited for that. Anyway, I know this was a long video, lots of rambling and lots of options and things like that. I still hope it was useful to you. And well, I hope to see you back in the next video. Thanks for watching. Bye-bye.